This is question number 28 from book number 1 based on the 2020 NEC, and this is electricaltime.com. How many 12-2 AWG type AC cables can be installed in a framing member hole without maintaining spacing between the first and second floor of a building where fire stop is used? The branch circuits supply power to 120 volt 20 amp receptacles. And the answer to this question, just want to take 30 seconds to let you know what we do here at electricaltime.com. We do online electrical classes from the comfort of your home. And then we also have this free service. So if you click on the subscribe for free NEC questions, Monday through Friday, you'll get an NEC code question and an answer sent to your email. All right, so back to our video. Is A, and that's going to be 4 AC cables. All right, so first question we're going to ask ourselves here is, what article are we talking about? And we are talking about Article 320. That's armored cable type AC, and that's within Chapter 3, Wiring Methods and Materials. And that's in Part 2, Installation of Article 320. And then we find 320.80, that's called ampacity. And then we find 320.80, and that is called thermal insulation. So let's go into our code books and let's go to 320.80A together. And here's what it says. Thermal insulation. Armored cable installed in thermal insulation shall have conductors rated at 90 degrees C. The ampacity of cable installed in these applications shall not exceed that of a 60 degrees C rated conductor. The 90 degrees C rating shall be permitted to be used for ampacity adjustment and correction calculations. However, the ampacity shall not exceed that of a 60 degrees C rated conductor. And it continues, and it says, where more than 2 type AC cables containing 2 or more current carrying conductors in each cable are installed in contact with thermal insulation, cork, or sealing foam without maintaining spacing between cables, the ampacity of each conductor shall be adjusted in accordance with Table 310.15C1. All right, so I suggest you read that again in your code book. All right, there's a lot of important information there. So let's take a look at how we solved the problem in our textbook. So step number 1. 320.80A says that when we have more than 2 AC cables with 2 or more current carrying conductors without spacing and in contact with thermal insulation, caulk, or sealing foam, we must adjust the ampacity of the conductors according to Table 310.15C1, which we call the adjustment factor, which we used to call derating. So if you hear somebody saying derating, you know that they're an old-timer like me, but you have to understand what we're talking about. All right, so let's continue. So if you hear an electrician say derating, you know what they are referring to. All right, so let's go to step number 2. 320.80A says that we can use the 90 degrees C ampacity to start our adjustment factor, but in no case can the ampacity exceed that of a 60 degree C conductor. All right, so let's go to step 3. Step 3, we're going to look at table 310.16, and that's my favorite table in the code book. That's the ampacity table. And we see that 12 AWG conductor at 90 degrees C is rated at 30 amps. All right, so let's go take a look at table 310.16 together. All right, so here it is, table 310.16. And I just want to make a special note here. The NFPA has a product called the NFPA Link. It's really cool. It's having the code book on your phone. I highly recommend it. And again, it's something called the NFPA Link. Go check it out. All right, so we've got here table 310.16. And what we were told that we are going to use the 90 degrees C column to do our initial calculation. All right, so the cables that we're using in our calculation are 12 gauge. And according to this table, they're rated at 30 amps. All right, so we start there. That's not going to be our final answer. All right, now, the other thing that we were told is that we have to be real careful about the derating. And let's take a look at this table here. And this is table 310.15C1. And, now we call this the adjustment factor. When you have more than 3 current carrying conductors. So if you hear somebody say derating, this is what they're talking about. All right. So we have to be real careful. In the example, we were told that these branch circuits are going to be 120 volts and they have to supply 20 amp receptacles. All right, so here's where you got to think a little backwards right now. So if we go back to our ampacity table, we see that 12 AWG conductor at 90 degrees C is rated for 30 amps, but I need a minimum of 20. So here's what happens. And again, we're asking how many of those, AC cables can we jam into that hole? That's the other question. So if I look at this and I see 4 to 6 current carrying conductors, and remember in the 12-2 type AC cable, there's going to be 2 current carrying conductors in there, right? We got the grounded, we have the ungrounded, and then we have the equipment grounding conductor, right? Or we can have that metal bonding strip that's in there. But we're only counting the current carrying conductors, and that's going to be the black and the white wire. All right, so if I've got 1 AC cable, I'm going to have 2 current carrying conductors. If I have 2 AC cables, I'm going to have 4 current carrying conductors. If I got 3 AC cables, I'm going to have 6 current carrying conductors. So if I have up to 6 current carrying conductors, I'm going to have an 80% here. And that means I'm going to take the 90 degrees C, which gave us 30 amps, and I'm going to multiply that by 0.80. And let's do that together on our calculator. So we have the 30 amps times 0.80, and that's equal to 24 amps. All right, can we put an additional AC cable in there? So if I go to 4 AC cables, that's going to give me 8 current carrying conductors. All right, so let's highlight that here. So right now, I'm in this row over here, 7 to 9. And that tells me that my adjustment factor is going to be 70%. So again, if I'm starting at the 30 amps times 0.70, that's equal to 21 amps. Now, what happens if I go to 5 AC cables? Then I've got 10 current carrying conductors. I got 10 of them. And if I got 10 conductors that are carrying current, I got a 50% adjustment. And that's based at the 90 degrees C for 30 amps. And that's going to give me 15 amps. So that's no good. I got to have 20 amps for those receptacles. All right, so let's go back to our textbook and see where we left off. All right, so in step number 4, we're going to look at table 310.15C1 and see that 7 to 9 current carrying conductors requires a 70% adjustment factor. And that's just what we saw. So step number 5. We take the 30 amps of ampacity from table 310.16 for 12 AWG conductors at 90 degrees C, and we multiply that by the 70% adjustment factor, which gives us 21 amps. So we got 30 amps times 70% is equal to 21 amps. So let's see what we got here in step number 6. Since our adjusted ampacity is 21 amps per table 310.15C1, our ampacity cannot exceed that of a 60 degree C conductor. We settle down to 12 AWG, which is good for 20 amps at 60 degrees C. So let's go on. So step number 7. Since these specific AC cables have 2 current carrying conductors each, we can only have 4 AC cables, which would give us 8 current carrying conductors. And per table 310.15C1, 8 current carrying conductors requires us to have an ampacity adjustment of 70%. And here, let's read, I have an additional note here. So note, if we had 5 12-2 AWG AC cables, we would have 10 current carrying conductors, and this would have required us to have an ampacity adjustment of 50% per table 310.15C1, which would have only permitted us a max of 15 amps. So now, again, just going to repeat. So we got 90 degrees C for the 12 AWG conductors, and that's 30 amps. And then we multiply that by 50%, and then we got 15 amps. And that's no good, because my receptacles, I need 20 amps for those receptacles. All right, so again, 15 amps is not enough to supply power to these 120 volt, 20 amp receptacles. We need a minimum of 20 amps, and therefore, we can only have a max of 4 12-2 AWG AC cables, which has 8 current carrying conductors. And again, the answer to this is A, 4 AC cables, and that is code reference 320.80A.